Hello students. Today we will be discussing some numerical problems based on gravitation. Starting with the first problem of today. Question number 1. If the force of gravitation between the earth and a body of mass capital M on its surface be 9 into 10 raised to the power 7 newtons, what would be the value of capital M? Okay, now we are given that there is a force of attraction existing between a earth and a body of mass M, and the value of that force is 9 into 10 raised to the power 7 Newton. We have to evaluate the value of that M. Now for this, we know that F, which is given to us, is 9 into 10 raised to the power 7 Newton. Next, we know about the mass of Earth. Let it be small m. That is 6 into 10 raised to the power 24 kg. Students, for solving the problems of this particular chapter, there are some constant values which need to be known. Sometimes they are available to you in the various examinations, and sometimes it is assumed by the examiner that they are well known to you. So, like mass of Earth, mass of Moon, radius of Moon, these should be known to you for this chapter. As I mentioned that mass of Earth is this, now radius of Earth. Radius of Earth would be 6.4 into 10 raised to the power 6 meter. As we all know that F is equal to G capital M small m over r square. As I mentioned that small m is a mass of Earth while capital M is mentioned in the question, that is the mass of a body. Now substituting the values, that is 9, F is 9 into 10 raised to the power 7, G is universal gravitational constant, possessing the value 6.67 into 10 raised to the power minus 11 into capital M has to be calculated into small m, that is 6 into 10 raised to the power 24 over r square, that is 6.4 into 10 raised to the power 6 whole square. Now solving it, we will be getting 9 into 10 raised to the power 7 into 6.4 into 6.4 into 10 raised to the power 12 over 6.67 into 10 raised to the power minus 11 into 6 into 10 raised to the power 24 is equals to capital M. Now the value of capital M on solving will be 9.2 into 10 raised to the power 6 kg. So this is a value of capital M. So the force, that is 9 into 10 raised to the power 7, exists between the mass of Earth and a mass of a body, that is 9.2 into 10 raised to the power 6. So this was our first question. Now let us discuss another question. The acceleration due to gravity at the moon's surface is 1.67 meter per second square. If the radius of the moon is 1.74 into 10 raised to the power 6 meter, then calculate the mass of the moon. Now, in this question, it is talking about the acceleration due to gravity. We all know that acceleration due to gravity is a small g and it is calculated as gm over r square. Now, by this formula, we know that small g is 1.67 as per question. Capital G has a constant value as we have used in the above question also, and R is given to us in the question, that is 1.74 into 10 raised to the power 6. So by substituting these respective values we can get the value of capital M. Now by using the above formula we can say that small g into r square over capital G is equals to m, that is mass of moon. So we can write 1.67 into 1.74 into 10 raised to the power 6 whole square over 6.67 into 10 raised to the power minus 11 is a value of capital M. Now, on solving it, we will be getting M as 7.58 into 10 raised to the power 22 kg. So, this is a mass of a moon. So, if the gravity is given, that is acceleration due to gravity is given, then we can use this formula. But if we are given that the force or gravitational force has to be calculated, then we have to use the above mentioned formula. Now, let us discuss another question. Question number 3. The mass of planet Jupiter is 1.9 into 10 raised to the power 27 kg, and that of the Sun is 1.99 into 10 raised to the power 30 kg. The mean distance of the Sun from Jupiter is 7.8 into 10 raised to the power 11 meter. Calculate the gravitational force which Sun exerts on Jupiter. Also find the speed of Jupiter. Now in this question we are given the masses of Jupiter and Sun and the respective distance between them. For that we have to evaluate first the gravitational force and then we have to evaluate the speed of Jupiter. Now going for first part of the question. First we will deal with the first part of the question, that is its gravitational force. We very well know that the force of gravitational is G m1 into m2 over r square. Now according to this formula we are aware of capital G, we are aware of m1, we are aware of m2 and we are aware of r also. So by substituting the respective values here we can state that F is equals to 6.67 into 10 raised to the power minus 11 into m1, that is 1.9 into 10 raised to the power 27 into m2, that is 1.99 into 10 raised to the power 30 over r square, that is 7.8 into 10 raised to the power 11 square. Now on solving it mathematically, we will be getting f as 25.22 over 60.84 into 10 raised to the power 24. On solving it further, we will be getting 4.15 into 10 raised to the power 23 Newton. So this is the force of gravitational which is existing between the Sun and Jupiter. Now in the very next part it is asking us about the speed of Jupiter also. Just now we calculated force. Now we know that when the object is moving in a circular path, then there is a centripetal force which is acting in its path towards the center. So according to that, F must be equal to that force, and that is mv square over r. Now talking of this question or equation, we know about F, and we know about M and capital R also. We know that F, which we have calculated, is 4.15 into 10 raised to the power 23. We know about the M as we have to evaluate for Jupiter. So the mass of the Jupiter would be taken into account. We know its mass is 1.9 into 10 raised to the power 27. And at the same time we know about the R also, that is 7.8 into 10 raised to the power 11 also. Now using this first equation we can find value of V. V will become under root of F into R over capital M. Now we are known for these all values. Substituting them, under root of 4.15 into 10 raised to the power 23 into 7.8 into 10 raised to the power 11 over 1.9 into 10 raised to the power 27. Now on solving this, we will be getting V equal to under root of 1.70 into 10 raised to the power 8. Taking its root, we will be getting 1.3 into 10 raised to the power 4 meter per second. So this is the respective velocity of the Jupiter. Okay. Thank you, students.